You have b raised to 4 minus 256. If we factor completely, we might try to look at the GCF first. But do we have a GCF for b raised to 4 and 256? No. This one doesn't have a number, so we don't really have a GCF there. But if you look at this, b raised to 4 is a perfect square, right? Because 4 is divisible by 2. How about 256? It's a perfect square. You have it there. What's 256? It can be written as 16 times 16, right? 16 times 16 is 256. So we can start from there, which means we can get the square root. Square root, square root, square root of b raised to 4. Just divide 4 by 2. What's 4 divided by 2? 2. When you get the square root, divide the exponent by 2 if it's in exponential form. How about the square root of 256? 16, right? So that would be plus 16, and the other one is b squared minus 16. Note, b squared plus 16 is a sum of squares. B squared minus 16 is a difference of squares. Sum of squares is prime. It can't be factored. It's the only factor of a prime polynomial is simply 1 in itself, right? So it cannot be factored further. So we know it's prime. So if this is prime, just copy, right? Prime, copy. And this one, factor. So you copy the prime factor and factor the other one. And so copying b squared plus 16 now, let's factor b squared minus 16. And we do the same. Square root, square root. What's the square root of b squared? Square root of 16? 4. So plus 4, b plus 4. The other one is b minus 4. You cannot factor this anymore. B plus 4. Although 4 is a perfect square, but b is not. Since the exponent of b here is 1 and 1 is not divisible by 2. Don't stop factoring unless all of them are already prime, right? So prime, prime, prime. Now we're done. There are two factors here, b squared plus 16 and b plus 4, b minus 4.